Welcome back to the shed. Well, this is my newest little engine, and this is the MUSA F1 2.7cc 4-stroke engine. Basically, it's a ready-to-run engine straight out of the box. You just screw the engine to the base, configure the wiring and the electronics, add some engine oil, add some fuel, and you're ready to go. So, looking at this engine, we can see the high quality of the CNC machining and attention to detail in the design. It's finished in a silver anodised layer and is very complementary to the brass components and the general features of the engine. This engine, the MUSA F1, is based on and a tribute to an American model engine builder, George Luhrs. George spent most of his leisure time building model engines of various sizes, and his legacy was to have built the world's smallest IC engine at the time, with dimensions as minute as 1/8 of an inch cylinder bore and 5/32 stroke length. This was seen as taking IC engines to the limit of miniaturisation, and it was reported that his miniature engine emitted the sound like that of a buzzing bee. How wonderful is that? Go on. Buzz off you. Go on. This MUSA F1 engine is based on one of his designs, but thankfully not based on his minute dimensions. Its shape and design reminds me of the vintage British cylinder lawnmowers, of which I have, well, more than I should have really, such as the Atco and the Suffolk engines, which use a fan and a cowling to force air through the cooling vanes on the engine. In fact, it would make a lovely little engine for a fully functional miniature model of a classic lawnmower. The engine is a 4-stroke cycle with overhead valves and uses tiny push rods operated by a dual cam system within the engine block. These rods operate the valves in time with the rocker arms, and when the engine is running, the valves are just a blur as you can't see them at the high revs per minute, but you can see them operating when slowed down. It has an enclosed crankcase and uses a splash-type lubrication system to keep all of the internal moving parts nicely oiled. The engine has a bore of just under 15mm and a stroke length of almost 17. This produces a 2.7cc displacement, providing 0.4 of horsepower, which is surprising for such a small little engine. The engine is equipped with forced air cooling, similar to the lawnmowers, via the internal centrifugal fan on the main drive shaft. This forcefully blows air across the cylinder body through the machined cooling fins to help keep the engine cool. Removing the cover exposes the centrifugal fan and the engine flywheel behind the cover. The ignition is generated by a standard CDI unit, which can generate 20,000 volts spike to jump across the plug gap, igniting the fuel in the cylinder. Two 18650 lithium batteries are used to provide the power for the CDI. This is triggered by a set of contact points, which is driven indirectly from the engine crankshaft. A small rotating cam operates these contacts, closing the points at the compression cycle to ignite the fuel in the cylinder. This is adjustable to control the advancement or the retardation of the timing to suit the engine's purpose. The closed points make the electrical circuit and send the HV to the spark plug. The spark plug used is the usual 1/4 inch by 32 threads ME8 spark plug, which is common for model engines. The manual says that the engine will run with gasoline or kerosene, or petrol/paraffin in the UK, although I have only used it with petrol up to now. I use SAE30 mineral oil in the engine sump and to lubricate the external moving parts. There isn't any reference to show how much oil needs to go in the sump, but the engine will let you know if it's overfilled, as the excess oil gets sprayed out of the hole in the filler cap. I've been there and I've still got the t-shirt, even after several washes. The fuel tank has glass windows at either end and is filled via the threaded cap. I drilled a slightly larger hole in the cap to allow me to fill with one of my needle bottles, as it's very easy to lose the cap on the floor when unscrewing it. Trust me, drill that hole before you find yourself on your hands and knees trying to find the little filler cap. It went down here somewhere. It's got a, oh, what's that? Oh, what's this? Oh, 10mm socket. And some nuts and bolts. And oh, there it is. Look. Why does it always roll right down to the corners? Hey. Yep, that's the one. Drill a hole. It's much easier. The carburetor is a very nicely made unit. It has a throttle lever which has approximately 60 degrees of motion between open and closed, and it has a lever arm which is very suitable for operation with the standard RC servo motor. An adjustable needle valve allows the carb to be set up to get the desired fuel-air mixture balance. There is a nice 3-groove pulley on the crankshaft, allowing connection to drive auxiliary machines, and also doubles as the starting hub, as it is fitted with a one-way needle roller bearing, into which is inserted the 6mm starting shaft, powered by a battery drill. As this is a one-way bearing, once the engine kicks into life, the shaft can be easily withdrawn, as it is essentially stationary now in the engine. A very nice idea indeed, which I think I'll be utilising on some of my other engines. Now the engine isn't supplied with an exhaust pipe, but it has a little manifold connection. So I built this lovely addition to the engine. The exhaust was made from an empty CO2 gas cylinder, which was drilled and turned to suit an extension pipe. And a brass connecting pipe was turned to connect to the cylinder manifold, and the opposite end was threaded and the bottle was tapped to suit. The wall thickness of the gas bottle was a lot thinner than expected, so I used a very fine thread and a lock nut, but if this doesn't last the test of time, I will weld a nut to the bottle for added strength. The new pipe adds that finishing touch to the engine, and it creates a nice throaty sound when the engine is running. Just too much. Oh. The fuel tank is quite small, and considering this engine ticks over at about 800 RPM and throttles up to 8,000 RPM, yes, 8,000 RPM, it is certainly a thirsty little beast, and the fuel tank could do with being a little bit bigger. Overall, this engine has really grown on me. At first I felt that due to its sort of high speed and high revs, the engine didn't really suit my usual run as slow as possible type of engines, but I have grown to love it. It came out of the box running and is just such a gorgeous little mini beast. Details of where you can buy this engine will be in the section below the video, where you can also get an exclusive discount code. I'd like to thank Enginediyshop.com, who have generously supported my channel these last few months. These engines really help me keep my grey matter firing on all cylinders. So for all of you at Engine DIY Shop, thank you. As always, a big thank you also goes out to all of you who have liked and subscribed to me over the years. If it wasn't for your kind comments and support, I couldn't do this. If you got to the end of this video, well done, and thank you for your support. And if you want to do a sticker swap with me, then please get in touch with me at the address on the screen. Cheers all, keep well and keep happy, and as always, thanks for watching. If you enjoy my videos and you wish to support the channel, then please buy me a coffee at ko-fi.com.